Hello everyone, I am Neha, Senior Research Fellow at University of Delhi, India. My research interests include artificial intelligence, machine learning and computer vision. Considering this as my first session with the students, I have chosen to explain the mathematical concepts that are being used in PCA technique. This is Principal Component Analysis technique. First of all, Principal Component Analysis or PCA is a statistical procedure that has applications in the fields such as face recognition. Moreover, it is a common technique for finding patterns within a data. To understand this technique, one should have the basic understanding of standard deviation, covariance matrix, eigenvectors and eigenvalues. I'll make use of a research paper, an Excel sheet and of my own notes to make the students aware or understand about these concepts of PCA. Let us start.
Let us start with this research paper, a tutorial on principal component analysis by Lindsay Eigen, February 26, 2002. This paper is very good for the people who want to understand the principal component analysis and the mathematical concepts related to it. I'll introduce you with the paper. The first section gives the basic understanding of principal component analysis, where it is useful and what are its applications. The second section, this gives the background mathematics of principal component analysis. The very first topic is the statistics, under which she has covered standard deviation, the variance, the covariance matrix. Second is the matrix algebra, which covers the eigenvectors and eigenvalues. And then she introduces the reader to the principal component analysis, how to take the data, then subtract the mean from it, then calculate the covariance matrix, the eigenvectors, the eigenvalues, and choose the component and forming the feature vector, how to derive the new data set, how to get back the old data, and what are its application in computer vision for finding patterns, image compression, and then the code. And finally she has given the post. So this is a complete paper for the understanding of principal component analysis. I'll start from the very initial stage, from the standard deviation. Why standard deviation is required when we have the mean? This data set gives the answer to this question. Here we have two data sets. One is 0, 8, 12 and 20. Another one is 8, 9, 11 and 12. The formula for the mean is summing up all the entries and dividing by the number of entries. The mean gives us the point around which the data is. But the standard deviation gives the spread of the data. It is the average distance from the mean of the data to a point. For both these data, the mean is 10. However, the standard deviation will be different and it will provide a very important information. The formula for the standard deviation is subtracting the mean from each entry and then squaring it and then summing it up and then dividing it by the number of entries minus 1 and then square root. Lindsay has showed this calculation very beautifully under this table for both the datas. First is for 0, 8, 12 and 20. This shows x minus x bar and here it shows the square. Here is the total and then it is divided by n minus 1 entries. Here n is 4. It is divided by that is 208 divided by 3 and then the square root of 69.3. A similar calculation has been performed for 8, 9, 11 and 12. Now the standard deviation SD for set 1 is 8.32 and for the set 2 it's 1.82. We can see that there is a significant difference between the standard deviation. The standard deviation for set 1 is higher, in fact much higher than the standard deviation for set 2. The reason being is the spread of data for set 1 is 0 till 20, that is there are significant difference between the lowest entry and the maximum entry. However, for the set 2 it's 8 and 12. This significant difference is showed in standard deviation. Thus the standard deviation is very important and tells us much about the data as compared to mean. The second comes before going to on the variance, I'll like to consider this data that has all the same entries. That is, if we consider data with 4 entries, each entry as 10, then standard deviation would be 0. That is, there is no spread of data, but mean will remain the same as 10. Next is the variance. Variance is also another measure for the spread of data. In fact, it is identical to the standard deviation. Only the square root is not there. Otherwise, it's the same. Now, is the covariance. The standard deviation and variance are purely for the one-dimensional data. But in PCA, we have the data in various dimensions and we need the correlation between various dimensions. Therefore, the covariance comes into picture. It is a similar measure that gives the relation between the various dimensions. For example, if I have the two-dimensional data, one is X and another is Y. Here I have two-dimensional data, one is X and another is Y. The plot for this particular data can be shown in this figure. The sum for X values is here and sum for the Y values is here. In this Excel sheet, I'll show you directly how the covariance matrix and covariance is calculated. First of all, the sum and mean is calculated. The next step is to subtract each entry of this data from its mean value. That is, I have given it the name of X average. That is to subtract this 2.5 from the mean as 1.81. You can do it manually and check, it will come at 0.6. And the calculation is repeated for all these values. And similarly, similar calculation is done for the Y data, Y minus Y bar. 2.4 minus 1.9. This will give us 0.49. Now, if I have to calculate the standard deviation, I would have summed up these values and then divided it to 9. These are 10 values, then I must have divided it to 9. But here I have to calculate the covariance. For that, the covariance between this and this. In this particular column, the covariance of X with X has been calculated. Here, the covariance of X and Y has been calculated. In this column, the covariance of Y with X has been calculated, and at last, Y with Y has been calculated. Therefore, we get the covariance matrix as, after multiplying each entry with everyone, we have summed up, and this gives the covariance matrix as 0.6, 0.62, 0.62 and 0.71. These are these entries. We can see that here this value and this value are similar because the relation of x with y and y with x would be same. One more thing I would like to tell you is that this data here has been transformed to this data here, that is this way. Here we have transformed the xy axis. Here the origin of the axis has been shifted from this particular position to this particular position. This is an essential step in performing the principal component analysis. Now let us come back to this paper, research paper. Here is a formula for covariance. The same calculation has been performed in the Excel sheet, that is xi minus x bar into yi minus y bar divided by the number of entries minus 1, and we got this covariance matrix like this. This is for the 3-dimensional data. We performed for the 2-dimensional data, so we got these 4 numbers. And I have also told you that covariance for A and B will be equal to covariance for B and A. That is that the matrix is symmetrical about the diagonal. The next comes are the eigenvectors and eigenvalues. To understand this, we need to understand what is the linear transformation, what is a determinant, and what is a system of linear equations. A system of linear equations is simple equations that we use in the linear algebra. Linear transformation means it is a tool that can transform the magnitude and direction of a vector, sometimes in lower direction,